I thought this was interesting when I looked up the whole conference, Linux Foundation, Zen KVM. One of the submission categories they had was an end user presentation. So I thought, hey, this will be fantastic. As an end user, I can come and actually talk about how we plan to use KVM Zen and how we're using it today. So I spoke at the Zen Developers Conference, Don't Throw Things at Me, on Monday, and now I'm here to talk about KVM today. So I will keep this to specifically KVM, but I'll answer questions for both if you have it. So again, I'm an end user. I'm not a developer. I haven't contributed to the upstream or anything like that, though I probably should at some point when we start getting really going on the path with this. But I thought it'd be a great way to kind of give you an end user perspective of how we use KVM. Maybe some of you are end users and you kind of maybe learn something from us or learn what not to do. Either way is fine, I suppose. This is something I put in. This is like the little slide or the thing you get in front of a TV show that says, don't do the stunts you're getting ready to see, that type of thing. So just a quick disclosure. I am presenting on behalf of myself. I do work at GE Transportation, but this is not in any way a GE Transportation presentation where we're selling you something or showing you our products or anything like that. This is basically Mark Kraeling using GE letterheads at the bottom of the slides, and then, of course, I am a GE employee. So keep in mind that this, if you've heard a GE person say something completely different, yeah, that can happen. So here's the agenda I thought we would go through. First, talk a little bit about the Locomotive System. That'll kind of give you a flavor for where we're thinking about using virtualization. Then I actually have some use cases for us and why we think virtualization is important on our locomotive systems. Third, I want to actually talk about what we use for a hardware platform, because it's certainly a lot different than what typically is used in maybe a back office. So things like 32 gigabytes of RAM, it's like, no, we have much, much less than that. So I do want to talk about that a little bit. And then finally, kind of wrapping things up is what we as end users at GE feel is important to us in virtualization. So hopefully a lot of that I'm actually going to talk about during the presentation, but this will be kind of a nice wrap-up at the end to kind of tie it all together. So just a little bit of background about GE Transportation. I did talk to somebody yesterday, and they said GE makes trains, locomotives. I didn't know that. So I figured I'd go ahead and throw these slides in here at the last minute. GE Transportation is a $5.6 billion business for GE, so we're pretty darn large. We sell locomotives not only to the U.S., but worldwide. We sell them to Saudi Arabia, North Africa, Australia is a big customer, Brazil. So we sell all over the world. Our headquarters are actually in Chicago, Illinois. They were moved there about 2 years ago. But prior to that, our headquarters was always in Erie, Pennsylvania, which is where our primary locomotive building facility is. And that facility is actually the third oldest GE facility that GE has. So we were number 3, I think, and it was built around 1910, 1915, something like that. Was when they started making locomotives. Obviously, the other industries that you see, they were kind of involved all over the world as far as GE goes. These are the sorts of things that we work on as products. And I promise you this will be the last marketing fluff slide. You can tell the marketing fluff slides because they look really, really good. My slides are not going to look so good, but it's one I borrowed. These are the different businesses that we're in. I am sitting up here basically in this top right. If there are electronics that are on board a locomotive, that's going to be in our business, in our cab electronics business. So we do different control systems, information systems, et cetera, again, on the cab of a locomotive, exporting lots and lots of data off the locomotive. A couple of products that we do have in cab electronics. The first one I actually just described to you. If you've ever seen a train that has 1 or 2 locomotives in the front and then a bunch of rail cars and then maybe there's a locomotive in the middle or the back, obviously there's no engineers on board. Any locomotives you see throughout the train, they're all basically controlled by radio control from the operator in the front. Another interesting tidbit is that those locomotives that are in the middle or in the back don't necessarily follow exactly what the front is doing. The engineer can command it to do something different. So if you think about a train that's 2 miles long going over a hill, it is very normal to have the locomotives in the front have full braking on, and the locomotives in the back actually have traction on to push the rest of the train up the hill. So it's basically a product called distributed power that is one of our products. Another one that I'll mention for cab electronics, a lot of the switchers or older locomotives you see in a yard, a lot of them will have a little yellow strobe light on it, if you've ever seen that. There's nobody on board those locomotives. There's people in the yard that have a little handheld unit and are basically controlling the locomotive, and it's a lot safer than somebody on the ground using a radio telling the engineer what to do, so that person can actually control the locomotive remotely. So it's like a giant train set, basically. Okay, so a lot of cool things I get to do, play with trains, drive trains, whatever. So it's a lot of fun. So this is me. Yes, the picture is about 5 years old. I keep using it. At some point, I'm going to not be able to use it anymore. But again, I work for Cab Electronics. I'm actually based in Melbourne, Florida. So I am not in Erie, Pennsylvania. So that's actually kind of a nice thing, as our Cab Electronics group is down in Florida. And I'm a product manager / architect. In GE lingo, I would always introduce myself as a product manager, because in GE, everybody knows what a product manager does. Outside of GE, like for instance in this forum, I am a product architect. I'm actually a product manager that doesn't have a product. Most product managers actually have a product. I basically work in the Cab Electronics group to define architectures. That is my job. So whether it's product or system architecture, even software architecture, that's what I do. My forte, because I started out doing real-time controls, classical definition of me as an embedded software engineer. So all my schooling, in fact, most of my experience has been doing embedded real-time software. I also do a lot of the wired and wireless communication designs for the products I just described earlier. And I'm a huge Linux and ARM guy. Everybody at GE knows me at this, because every time I walk into a meeting and they talk about other OSs or other architectures, I'm the one who says, why didn't we use this, or can't we use this, or did you consider this? So I am known around the circles at GE at being the Linux and ARM guy big time. So hopefully that is okay with people in the room. Nobody's throwing things, so I guess that's good. So I want to talk a little about the locomotive system. The locomotive system is basically defined as, the easiest way to do it, it's a power plant on wheels. There's a very large diesel engine, typically between 12 and 16 cylinders, that generates power, and the power is basically put to traction motors, electric traction motors. This is not a mechanical device, meaning the motor itself, the 12 or 16 valve engine, is not directly connected to the wheels. There isn't a transmission in the world that can handle 4,400 horsepower. So even the haul trucks that you see running around the mines, it's all electric drive. It's the only way you can do it. Mechanical linkages wouldn't be possible. With having a power plant on wheels, one of the things I always tell people is things like weight are not important. The more weight a locomotive has, actually, the more traction you'll have for the wheels on the rail. In fact, a lot of locomotives, when they're rebuilt or built with newer engines that might be lighter, they actually add weight. They'll add huge concrete blocks with steel in them, whatever, just to add weight. So weight's not a big concern. For us, really, power's not a big concern, right? We got a power plant on wheels, so whether I use 10 watts or 8 watts, it really doesn't make any difference. For us, in our electronics design, the most important thing is heat, heat, and heat, which does kind of translate to power. All of our electronics need to operate minus 40 to plus 70. The middle of Australia gets really, really hot, and a lot of you know northern Canada gets really, really cold. So we need to survive basically all those different temperature extremes. I do have a couple of videos, and I'm going to kind of talk through them. Hopefully the sound will be turned down enough where I can talk over them. So for us, it's actually all about information. When we start thinking about virtualization, yes, I got to it 10 minutes in just like I scheduled. For us, it's really about information. So what I want to show you in this video, we have a locomotive that's basically proceeding to a siding, and there's another locomotive that's supposed to meet him there. We're going to go to the right. That other locomotive is sitting on the left. Now, a couple of things you're going to see in this video. Number one is that at this point, with the data on our locomotive and the data on the other locomotive, we know there's a problem here. That other locomotive doesn't have any more air. It's still moving, so the driver cannot stop the train. He knows this, but us as a locomotive coming into the siding, we really don't know. The signals are actually set for us to be just fine to go into the siding, but we don't know that that locomotive is actually, you can see it just creeping And if you look right here, the guy's actually going to jump off. That engineer's like, I'm out of here. See, he jumped off. And oops, big collision. Locomotives are right around $2.5, $3 million. The cargo on board, also expensive. If things like vehicles are on board, guess what? Railroad company may be paying for a lot of vehicles that just got hurt if they're sitting on some cars in the back, brand new Fords, brand new Chevrolets, whatever may be getting shipped. Another video, again, talking about information. This engineer is assuming, because he sees another train parked there, that he's actually going to go on the siding that doesn't have a train on it. But he's not. He's actually supposed to go and sit at this siding while another one comes in. He just now realizes it and knows he's going to hit the back of this train. Now again, the signals were aligned for him. Just by the way, that little aluminum foil-looking stuff is quarter-inch plate steel. Okay? It crinkles like that when you hit it with a lot of force. Again, we know a lot of information about us moving, signal aspects, the way the track is aligned. We know the other locomotive's sitting there. So when we start thinking about virtualization, we actually want to run multiple sets of software concurrently at the same time on our locomotive hardware. Now, some of that software might be written by third parties. Some of it may be written by GE, but that's what we want to do, is have it all running on the same platform. So let's jump. This is the way GE, in fact, I think a lot of people probably used to do things. As soon as we wanted to have an application or we thought of a new product, we'd find a box, we'd find a software team and ask them what OS they wanted to use. We'd put a cell antenna and a GPS on the roof, and basically it started looking like that. Everybody, their own box, their own OS, nothing talked together. Everybody had their own cell phone plan, and we started basically putting all kinds of boxes on locomotive. What we started to do, and this was kind of the first step, is we took all of those boxes and said, okay, you don't get your own cell phone modem anymore because we're tired of paying cell phone bills. And the customer was too, I'll be honest. And we started networking them together into new hardware. I actually have it up here. It's extremely hard to see, I know. I'll kind of hold it up. But basically, this is what a standard locomotive platform looks like. It's extremely heavy. This is a 4-slot version. That's an 8-slot. But basically, it has one wireless card, LTE, that everybody can use, a lot of networking ports. And this particular box, which I'll talk about more in a second, actually has 2 processor cards in it. What we'd like to be able to do, if we start moving to this slide, is get rid of those boxes and actually have the applications move to those cards. That's GE software, third-party software from other suppliers, and even the customers go and write their own as well. So we want all of that software actually running on those 2 cards, maybe even migrating between the 2 cards as conditions change. So again, that's what we're thinking. Whether it's business apps, customers' apps, GE apps, third-party apps, we all want them to run on that virtualization, mobile data center, for lack of a better word. So I'm going to kind of jump through these use cases. Again, this is exactly what we always did. I was hoping to see some nods or something, so maybe we're all goofed up. But this is what we always used to do. We got a great idea for a new product, great idea for a new solution. We'd go and create our own box from some supplier, proprietary. Again, most times ask the software engineers, what OS do you guys want? How much memory do you need? And they'd give some sort of an answer based on the thought of the day. Then they'd go and write an app, and when it was done, we plopped it in a box, and it didn't talk to anything else. It certainly served whatever purpose it was serving, but it was not part of an overall network strategy. So that is exactly what we used to do, and that we're moving away from as we speak. In fact, the platform you see here has actually been out for about 3 years. So one of the things for our use case that I'll put together for GE Transportation, obviously the first benefit for us is cost reduction. So instead of having 6 or 7 or 8 different black boxes all doing their own thing, all with their own obsolescence plan, parts are going obsolete, some have power PCs, some have completely different processors, we thought it'd be much more effective to move to a virtualized space where we can actually reuse existing hardware and have more utilization. Second, we want to try to have a way that we can actually separate our software applications. I did mention that we actually have software applications running on this written by different people. So if they crash or they need to do a reboot or something, we don't want it to affect all the other operating systems and applications that are running in the system. So we see it as being able to do that. And secondly, an area that we're working in right now is actually having what we call high availability. So we want to label applications as this is the most important thing that needs to be running. So if we do have a hardware processor card go down or processor module go down, we'd like it to actually move over dynamically to the other hardware and keep running. So that's another use case that we have for sure. Next one is flexibility and scalability. Once we start getting into thinking about, okay, whether it's OSs written by particular third parties or by GE, we also like to have the flexibility of separating a lot of our different software elements. One of the things that we get into at GE Transportation is if we have a very large software image and maybe there's a couple of applications that are running, if we go and change one application, especially if we're thinking about something that's has some safety implications to it, we end up having to go and retest everything that's in that application. Now, certainly you can do an analysis and say, well, I changed this here, I shouldn't have to do that, but the point is that we do at least have to retest portions of it. And in fact, we have to do an overall system test, which can actually take quite a bit of time and resources. So by us going and separating some of these functions out, we see it as a nice way to be able to make changes internal to that application and not have to go and retest the entire system. This is kind of a summary of all of our use cases. The one that I did want to mention, it's in the top right corner there, that we've just started really taking advantage of is something I'll just call sandboxing. Maybe that's a general industry term. We really, really, really love to have the flexibility of releasing software that, quote unquote, isn't quite ready yet. At GE, when we go and put software in a locomotive, we may not see that locomotive again for a very long period of time, months. There's been locomotives that have had incorrect software releases running on them, and it can take months for us to actually catch up to it to put software on. Locomotives, being such expensive assets, don't stay idle very long. They go to a yard, they get serviced very quickly, refueled, add water, add coolant, whatever sort of things. They do their safety checkout. They're checked every 24 hours for a daily inspection, but then they're on the next train moving something along. Not dissimilar to an airplane. Delta Airlines doesn't have airplanes just sitting around in random cities, just as spares. Locomotives are very much the same way. So with sandboxing, it actually allows us to take an application that may not quite be ready yet. We know that even if it runs for 15, 20 minutes before it crashes, or maybe it collects data only in the morning and doesn't run in the afternoon, we know that we can actually put that application on our platform, have it run, provide some useful information, but then again won't interfere with the other applications that are running in our system. So that's a huge one for us that we're just now starting to take advantage of. Okay, so let's talk about our hardware platform. Everything for us basically resides, and you see, and I know in the back it's probably more difficult to see, I'll hold it up one more time, but basically resides in this particular chassis that you see right here. Over here on the left, your left, is a router card, and then there's actually two processor cards with virtualization installed, and the one over here on the very far right with those funny looking orange things sticking out, that's our network storage device. So our network storage device basically has two modules of 4 terabytes each. So it lets us do a lot of different things. We can, pixie boot off the processor cards, run images off the network storage. And in the situation where we have high availability applications, those applications are resident on our network storage device because obviously if you have your processor card go down, which has local storage, if it goes down, that image is not going to be available. So we want to do something like this, modules instead of these black boxes. Again, simplification, reduced cost, I already mentioned, freeing up space, and then lastly, with high availability, having some redundancy on board. So now I'm going to jump right into the modules that we have to give you kind of some information, the context, which I think is important. We have what I'll call networking-based modules. The array card, by the way, our network storage device, I consider that a networking card. That one in particular in this case has a Freescale LS1021 processor on it. a 32-bit ARM device. It does have the virtualization extensions built into the V7 ARM architecture, which is nice. And we do have a variety of processors. I'll cover the other one, our other primary one that we have. For these types of architectures, networking-based, right now we're using KVM to support those. On 64-bit, which we're waiting for, certainly not quite released yet for us and the flavor that we're looking for, we're definitely targeting the A53 series. And I didn't say it. It's on the next slide. Maybe I'll just jump to the next slide. No, I won't. I'll talk about it. Our processing cards that we have today that I discussed that's in this chassis, they're both x86 based. I do have a slide in a little bit that talks about what those are. Let me give you another one to maybe get tomatoes thrown at me. For our x86 modules, we're actually using Xen. So we're using KVM on ARM and Xen on x86, and I'll talk about that here in a little bit as to why. Here's our processors that we use for our 32-bit ARM environment. Again, the LS1021, you can see there, 2 gigabytes of memory. We've got an mSATA device. The thing we like about it the most is it has an ECC bus throughout the part, which is great for a lot of the things that we do that are more networking-centric. So for us, this is basically our go-to processor for the different things that we use that are data-intensive. The second one that we're using is the Zinc 7020. Whenever we have interfaces that we have to support that are a little different, that aren't standard, that aren't networking-based, this is the processor that we turn to. We basically have a gig of memory on board. You can see the NAND and mSATA. And then, of course, with the Zinc part, a lot of you know, the nice thing about it is it's dual-core ARM part, but then it has logic cells and DSP slices on board. So we can go and program the fabric to do whatever we need it to do. So if there's a specialized thing we need to drop down, if we wanted to do something relative to time-sensitive networking, very easy to put those things right down on the fabric and use them. So those are the two that we use. The processing-based ones, which basically just have a raw application that we need to run, we've got two variants. The first is an E3845. It's an Intel Bay Trail processor. It is a quad core that runs around 1.9 gigahertz. That is pretty much our standard. In fact, the two cards that I have up here today are that flavor. The one that we're launching and actually testing with right now is an Intel Broadwell processor that was released in the first quarter of 2015. It's a 5500U. It's actually a dual core. It does have 4 threads, right? So that's how they kind of walk around that one. Now, one of the things that you'll notice is it's certainly a lot different than the quad core, i7, 32 gigabytes of memory sort of processor lines. And the biggest reason for that is that all of our processors that we have in this box, again, with 70 C ambient temperature, there are no fans. So we spend a lot of time getting our heatsink design right, getting our heatsink for the RAM design right to make sure that our platform can operate at 70 C with no fans. I can tell you that even running that 5500U, Broadwell is pretty difficult to get there. So certainly if we went to a more traditional i7, we'd have no chance of getting there. That one, I think, is around a 15-watt processor. So it kind of gives you an idea. A lot of the desktop ones are 35, 40, 65. So that one's actually a 15-watt processor. The Bay Trail runs around 10 watts. And again, that's just for the CPU, basically running full out. To date, we've used Xen for these. Why, you ask? Well, because when we started with our Bay Trail processor third quarter of last year, KVM just didn't work right. And maybe lots of improvements have been made since then, I'm sure. But the amount of overhead that was basically going on with our little Bay Trail processor with 4 gigs of memory, it just wasn't keeping up. When we installed Xen, it worked pretty well, so we kind of went with that. Certainly over the next 6 to 9 months, we're going to try to consolidate so we are not using 2 completely separate families for hypervisors. We'd like to do one or the other. So we're going to be reassessing this, but it's just kind of one of the things that we've done to date. And yes, we don't want to have to support 2. As an end user, we don't have to support 2 if we don't have to. I'm going to throw this up too. We have started looking at Linux containers. I did say don't shoot the messenger. We feel like there could be some importance for us using Linux containers, but we don't see actually using Linux containers outside of using either Xen or KVM. So we think it might be a really effective way to, within a guest OS, actually being able to separate our applications a bit. Again, using the same kernel, but now going and actually having applications be more separate. And I think it's actually just going to help our whole testing scenario. So it's maybe makes things a further level of instantiation for us. So we don't see actually using them without a hypervisor, except maybe in the 32-bit case where we just don't have enough processor horsepower to handle basically handle KVM. So this is, again, my opinion, based on development to date. So for Intel, again, we said we're basically using Xen. 64-bit ARM, that's where we're really going to make sure that we use KVM. That's our target, though the processor that we're looking to use isn't quite out yet. It'll be out next year. And then for 32-bit, I did put a circle around KVM there at the bottom because I know it's low. That is something that we're going to reassess. Just because we had poor luck basically a year ago now, certainly doesn't mean we're going to have poor luck now. It's just development times, et cetera. And we had to kind of make a quick decision and move on it. So, that's kind of the thing to date. And certainly if we have questions at the end and want to entertain that, we can do that. I'm kind of targeting to have about 10 minutes at the end for questions. So what's important to us in virtualization, kind of the last section here? For us, boot times are not important. So I know I went to a couple of discussions throughout the conference talking about boot times. That's not important because for us, once an application's up, it's going to stay up for days, weeks, months. The Locomotive just doesn't get turned off. So for us, boot times is not very important. For 32-bit processors, certainly the amount of resources that are required for any hypervisor we use, that's probably the most important thing for us. Low CPU and RAM memory overhead. If we only have 1 gigabyte to deal with, we certainly don't want to have to devote a large portion of it to KVM. We need to have some of that devoted to our guest operating systems. So the overhead of switching, et cetera, going between guest operating systems is important. For our 32-bit space, I'm guessing that we would like to have target around 3 guest operating systems running concurrently if we could. Probably not more than that. We'd probably have one be like a supervisor, kind of checking to make sure everything else is okay, that the other 2 guests are fine. And then the guests would either be split by application type or be split by actual supplier. So we may have one supplier write software in one space, another person write software in the other space, and then have a supervisor that kind of overlooks the whole situation. Local management of guests. This is one that we are dealing with today. It's basically making it so, how do we go and make it so that we can have applications automatically restart, make sure that somebody's not starting to use more resources than he should, behaving badly, et cetera. So the way that we've thought about doing that is basically, as I said in the previous slide, having like a supervisor guest that kind of overlooks the situation everywhere else and works with the hypervisor as to what the condition is. Certainly for us, having better pool management and migrating of guests, I mean, we literally will have, in any given platform, in fact, this 4-slot one right here, we have 3 32-bit ARM processors running. I would love to think of things just as applications, since everything is very networking based. If we have a card that's heating up, all of our modules have at least 4 temperature sensors. So if for some reason we have a module that's heating up, maybe the PoE is being stretched, power over Ethernet is being stretched. Migrating applications from one card to another card and having them communicate over our Ethernet backplane would be ideal. So the whole guest management thing is something that we really need to focus on at GE, and anything in the industry that's done in that regard will be helpful for us. Lastly, standardized imaging. We have dealt with headaches and headaches and headaches of this, and I'm sure there's ways around it. But we want all of our OSs actually, because we're not running them in a data center, a centralized data center, and we're running them in a distributed fashion all over the network. We want these images to move freely from one hardware space to another. So freeing up any sort of UUID fixes, et cetera, is just a good way to for us to be able to manage applications. The other thing that's interesting is that whenever we do have a hardware fault and it goes into a service shop, they literally are going to pull a module out, all these modules that are up here. I know in back you can't see it. You literally take one out and put one in. So if it has a fault, they're going to yank one card and put another one in. So us being able to manage and say, okay, we're going to load you now with the correct software because maybe that card has been sitting on the shelf for 2 years. We're going to load you with the right software, make sure you're running the right image, et cetera, et cetera, et cetera. I think our whole time frame for how long we need to support software and support hardware in the field is probably longer than most. So it's very difficult for us to just upgrade to new kernels whenever a new kernel comes out. We kind of need to fix on something. When we sell hardware or software to our railroad customers, we basically give them a 15 to 20-year support package on it, which is an extremely long time. So we tend to keep our stuff around a lot longer. Locomotives that you see in a rail yard, most of them were built between 1950 and 1970. GP38s are you'll see those on the road all the time. Those were built in the 1960s. So they just keep reusing equipment over and over and over again, repower it, replace the wheels, replace the traction motors. They're used to keeping and using stuff for a very, very, very long time. I did want to show this as a kind of a typical configuration that we may use. In fact, the left side of this slide is exactly the way that this is configured right now. Is we have a hypervisor base running on 2 of our Bay Trail processors. The array actually holds the images, and then we basically just say start, 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 and when they start, they basically go to the application card that's most appropriate. We don't care because it's pulled together, and off they go and they run. Our Broadwell sort of series, again, sort of thing, kind of maybe more heavy lifting. Maybe you have the images, again, directly on the card itself, running on the mSATA drive. And then I did mention we're looking at using some sort of containers here on a particular image. I did put Ubuntu up there. We're not fixed on any particular distribution. Our customers very regularly run Red Hat Enterprise Linux. And again, ours is an open platform, so if somebody wants to use a different operating system than what we have, they can. Another one that comes up a lot with our x86 processor line is Windows. A lot of countries, application developers in Brazil, use Windows 7, Windows CE. They use a lot older, quote-unquote, older operating systems than what we may be used to here. And when we sell this platform, again, we have developers in Brazil, South Africa, and when they go and write their software, a lot of the older kind of quote-unquote older operating systems that you might figure come into play with this platform as well. So just because I put Ubuntu up there, don't think that I'm stuck on Ubuntu. It can be any particular OS that we may need. So getting to the conclusions, hitting the times right here, I think you can kind of understand, and a lot of things I talked about, whether it's customers, other suppliers, GE, writing software, virtualization has to be a standard product for us. We need to run all of those applications concurrently, ideally on the same hardware platform, so virtualization is going to be a big play for us. 32-bit hardware, again, I did say that when we assessed it, it didn't quite have enough horsepower to date to run it effectively. Our wait times, et cetera, were a little off. But we're going to take a look at that again to see, because we would like to have, again, since we have so many 32-bit ARM processors on our platform, we'd love to have the capability of moving around images freely. And lastly, 64-bit hardware, we're not going to launch it without virtualization. We're going to make it standard right out front. We do have some 32-bit processors where we had older software, and that kind of got inherited and brought along. But when we start with our 64-bit processing line next year, we're certainly going to virtualization right out of the box. And lastly, I did want to mention, too, we kind of expect our 64-bit ARM platform to maybe offload a little bit of our x86 development. Right now, the x86 processors is great for application, collecting data, offboarding it to the cloud, et cetera. It's got certainly a lot of horsepower to do that. We're hoping the 64-bit ARM processors that we select will be able to start running some of those sorts of applications as well. And with that, I'll open up for any questions with 10 minutes remaining.
Hi. So what do you use for orchestration? Do you use like a locally install management tool to manage these and install these VMs, or do you use OpenStack, or what do you use?
So the question was, what tools are we using right now to manage the different virtualization environments? Right now, we're not using any particular tools. We're trying a lot of them. OpenStack, you mentioned. Zen Server is another one. So we're kind of Zen Center. So we're trying out a lot of different ones. Right now, we do not have a standardized tool. That is one of the things our customers are asking for, is how are you going to support these things in the field? So certainly if there are people in the room here that work at companies that have those sorts of tools and solutions, I'd love to hear about them.
And you mentioned earlier last year when you used KVM compared to Zen, you ran into some problems.
Yep.
Can you throw some light on that? What kind of problems? Is it with networking or storage or just pure performance? Where exactly did you run into problems?
Yeah, so the question was, what sort of problems did you run into when you tried KVM last year? For us, we basically just did a straight, on our x86 platform, we did a straight KVM Zen. We installed them both, and then we ran processes in each of the guests. I think we did 4 guests, and then measured how much time it took for switching between the guest operating systems and the amount of RAM and CPU that was being taken up by the hypervisor. I'm not saying it's entirely completely scientific, but for our hardware, which at the time was the Bay Trail E3845, maybe at the time Zen had better support for the drivers in that space. Again, pretty non-scientific, but we kind of had to move quickly, so that's what we did.
Okay. And you mentioned that the VMs, they should not use the UUID, but I'm not sure what kind of user space applications you're going to run there, but the licensing is usually tied to the UUID. So have you guys thought about how licensing of the guests are going to work?
No, we have not.
Okay.
One of the things with licensing with the companies that with either GE has worked with or our customers, like a CSX, BNSF, whoever have worked with, typically when things like that have come up where, hey, the licensing is tied just like this, maybe because it's GE or maybe it's because they have big names too, companies so far have been very willing to figure out how to work with us. I know Red Hat Enterprise Linux is one that's worked very well with, said, okay, I understand how you're trying to do this. Let's do a different type of licensing. So maybe it's more of a deployment license as opposed to individual.
Okay. Thanks.
Yep.
For Zen, are you using paravirtual domains or HVM domains?
HVM. Yep.
I wanted to ask whether you are actually running any train safety critical applications on that or using separate boxes for that.
Can you repeat the question one more time?
Whether you are using any train safety critical applications on that, like in Europe we use the European train control system, which requires a lot of paperwork on top of that. So
right. Excellent question, especially since I did say safety critical. Maybe didn't say safety critical. I said safety important. Right. I always stay away from that critical word because that means something very, very specific. I can tell you, GE has not, nor has plans to have safety critical applications running in a hypervisor type of environment. For us, it's all about voting methods. Multiple processors looking at all the same data and having a voting type of architecture. So it doesn't really fit with this.
Yeah, that's used in Europe too, so that's why I was asking.
Okay.
Thanks.
Thank you.
Can you talk about the different use cases you have for ARM32 versus 64 and why you'd pick a 32-bit processor over the 64-bit one?
Yes. So I'm going to probably answer your question in probably reverse order. One of the things for us, and I did mention a couple of times, heat, and more heat. We can't handle heat. So the 64-bit ARM designs that we had to date that we evaluated, whether it was from Cal Zeta last year, some newer ones this year, the number of watts that a 64-bit processor for even ARM used was too excessive based on the performance that you got. One of the reasons why we picked the A7 ARM core was because it had more MIPS per milliwatt than any other ARM Cortex-A series line. So again, we kind of target that. However, we think with more introductions, I should say, of some A53 designs with some core die shrinkage, that next year we'll be well positioned to actually pick up and start using 64-bit.
So given that you're not short of power, but you do have a heat problem, what's the reason for not using fans?
Okay. Excellent question. Why in the world just don't you use fans and be done with this? Interestingly enough, and you can probably see a little bit better, there's some slots on the bottom of this chassis that are about 2 inches high that are designed for fan modules. And there's backplane connectors in there to accommodate such fan modules. But our customers don't like fans because they see them as a maintenance issue and nightmare and cleaning out filters and stuff. Again, these locomotives, when they launched them, they just wanted to run. We have worked directly with our customers to explain maybe more about, hey, if you keep things cooler, your equipment will last longer, things like that. And we're starting those discussions and having it. But for the electronics to date, they've been so used to not having fans that we've spent a lot of time designing processor architectures, heat sink design, and the ruggedness of these things to not require any fans.
Do you have any plans to support over-the-air updates or such a thing?
I'd say that one more time, I'm sorry.
Over-the-air updates, so you have an LTE board on it and so?
Yes, absolutely. Yes.
Okay.
I don't know how else to answer the question. This is getting real specific to locomotives. GE has a program right now that's launching actually in the fourth quarter where the control system, the displays, things that are on board the cab will actually be updated by back office. So the way it works is that the back office will transfer all of the data, images, software images, et cetera, to a central repository and sit on there until time that it can actually go through the real physical update. So all the software is transferred. It sits resident, network storage right here. The locomotive has some time. That's important. If it's got to come in, go, there's no time. But if it does have time, whether it's the fuel depot or a service track, a maintainer will get on board. He'll have to answer some questions like, is the handbrake on? Do you have 45 minutes to do this update? Whatever the case may be, and he will actually on the screen go and launch the update. And it'll tell him, hey, come back in 45 minutes, it'll all be done. So the update process is all managed right on that box, and it goes and actually updates all the software on it. That is, let me jump to why I think your question is really, really important. We need to figure out as we move forward, even though we have guest operating systems running, et cetera, we need to update portions of that operating system. We don't want to have to update the whole thing because transferring that much data over cell obviously gets expensive. And then second, just going through and doing the actual update, So we're trying to focus on things within the guest as opposed to actually updating the whole entire guest itself.
So this isn't as much a question as maybe an advertisement. You mentioned that you were concerned about how to manage the guests, and also you've said that in some cases you use Zen, in some cases KVM, in other cases you're thinking about containers. I just wanted to point out that, and also it seems like your management case, it doesn't really fit any existing management tool that I've heard about, so you may end up writing your own. But I just wanted to point out that the libvirt library was written specifically to be able to talk to multiple different hypervisors, including Zen and KVM and containers, and it might make it easier for you when you decide to switch from one hypervisor to another.
Okay.
So,
I appreciate that. Thank you. Any other questions or comments? Okay, well, I really appreciate the opportunity as an end user to speak to you all today. I hope you enjoyed the presentation. I'll see you throughout the conference. Thank you.